Hmm. Hey guys, good evening and welcome back. Welcome back again to your Unacademy NEET English channel. I believe all of you are doing great, having a good time. So people, let me know quickly in the chats if all of you can hear me. If I'm perfectly audible and visible to everyone. Quickly, let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Everyone in the chats, people, quickly. Everyone in the chats, quickly. Perfect, perfect, perfect. All right. All right, guys. Just give me a second. Let me fix certain things and we shall be starting. Just a second. Just a second. Perfect, guys. Perfect. So, as you all must be knowing, today we are going to do some top 100 questions of the chapter Thermodynamics, right? Whatever questions are mentioned in your NCRT, first we are going to do those questions. Then we shall be solving the questions which have been asked in the NEET examination, the PYQs, the NEET PYQs of this particular chapter. And at the end, we shall be solving the JEE Mains PYQs of this particular chapter as well, right? And I think when I was looking just the slides, I think all the problem patterns which can be asked from the chapter Thermodynamics, all those things are included here in this particular session, right? And my dear students, at the end of the session, I shall be sharing the handwritten PDF of this particular session in my Telegram. I hope you guys are already part of it, right? If you are not, then be the part of it as soon as possible, right? The name of the Telegram channel is Wassim Bhat Chemistry Official, wherein I keep on sharing the handwritten PDFs of the sessions which I take live on this particular session. Okay? Perfect. So, are you all ready? Are you all ready, people? Let me know in the chats. Are you all ready? Are you all ready with your pen and paper? Because you are going to solve the questions. You are going to solve the questions, people. Let me know in the chats. Are you all ready with your pen and paper? Perfect, perfect, perfect. So without wasting any sort of a time, let's get going. Let's get started directly with the first question of the chapter Thermodynamics. My dear students, look at the question carefully. Look at the question carefully and let me know exactly the answer of this particular question in the chats. Everybody. Everybody, people. 2 liters of an ideal gas. 2 liters of an ideal gas at a pressure of 10 atm expands isothermally into a vacuum. Here comes the point. Expands isothermally into a vacuum until its total volume is 10 liters. How much heat is absorbed and how much work is done during the expansion? This is the question. My dear students, I just picked 2 points from the question. 2 points I picked from the question and we are done by just picking those 2 points itself. What are those exactly? First of all, it's mentioned that expansion of the gas is happening in vacuum. So it is basically the case of free expansion. It is basically the case of free expansion of an ideal gas. Number one. Number two, in the question they are mentioned that the ideal gas is undergoing which process? It is undergoing isothermal process, right? Well, you must be knowing, in case of free expansion, expansion in vacuum, expansion against zero external pressure. What is the work done? W value is going to be 0, number 1. Number 2, when the ideal gas undergoes isothermal process. When the ideal gas undergoes isothermal process, its delta U also has to be 0, right? Because in isothermal, temperature is constant, delta T is 0, and if delta T is 0, delta U, NCV delta T, that comes out to be 0 only, right? So W is 0, delta U is 0. Therefore, if I use the first law of thermodynamics, delta U is equal to Q plus W. So I would say delta U is 0, W is 0. Therefore, Q is coming out to be 0 over here. So with this, the question is done and dusted. This is something you were supposed to check. These were the two things which you were supposed to check. The first question was, how much heat is absorbed? No heat is absorbed or released during the process because Q value is coming out to be 0, number 1. Number 2, how much work is done during the expansion? W value is also 0. So both the terms are coming out to be 0 over here in this particular question. Am I clear with this? Am I clear with this? Just let me know quickly in the chats. I believe you can solve this sort of a question on your own when it comes in your exam. My dear students, look at one more question. Look at one more question. A swimmer coming out from a pool. Wow. A swimmer coming out from a pool is covered with a film of water weighing about 18 grams. A swimmer is coming out from the pool, right? And it's covered with a film of water, and that film of water has got the mass of 18 grams. How much heat must be supplied to evaporate this water at 298 Kelvin? Calculate the internal energy of vaporization at 100 degree. That's the question. Calculate the internal energy of vaporization at 100 degree. Look at the question carefully, guys. We are supposed to calculate internal energy change during the vaporization of water. So what is vaporization of water? Vaporization of water means H2O liquid. H2O liquid getting converted into what? H2O gas. This is the process which has to happen. This is the vaporization of water. Liquid getting converted into gas. Perfect. Now, first of all, we have got 18 grams of water as per the question. We are given with 18 grams of water. That means how many moles of water we have? If you ask me, how many moles of water we have? It's going to be given mass of water in grams divided by molar mass of water. The value comes out to be 1. So, basically 1 mole of water has to vaporize. 1 mole of water has to vaporize, people. Correct? 1 mole of water has to vaporize. I believe you already must be knowing about one thing. What is that? What is the value of delta H vaporization of water? If you do not remember it from now onwards. It is 40.66 kilojoules. This is the enthalpy change of vaporization of water. Enthalpy of vaporization of water, right? 40.66 kilojoules. If you do not remember this value, so remember it from now onwards. Because in some questions, they won't give you the value, which is basically the enthalpy of vaporization of water. So remember it. Now, guys, if I ask you what is basically going to be delta Ng for this particular reaction, delta Ng is equal to number of moles of gaseous products minus number of moles of gaseous reactants. The value comes out to be 1. So delta Ng is also 1. Perfect. Now, I believe you all would be familiar with the relation between delta H and delta U. My dear students, you know your delta H is equal to delta U plus delta NGRT. This is something which everybody should remember, right? What am I supposed to calculate? I am supposed to calculate delta U. So delta U has to be equal to delta H minus delta NGRT. Perfect. What is the value of delta H? It is 40.66 kilojoules. 40.66 kilojoules, right? Minus. What is the value of delta Ng? Delta Ng value is 1. What is the value of R? R value is 8.314 joules per Kelvin per mole. What is the value of temperature? 100 degree. 100 degree means 373 Kelvin. My dear students, if this particular term is in kilojoules, that means this term should also be in kilojoules. But since you have used the value of R as 8.314 joules per Kelvin per mole, so I'll be dividing this particular term with 1000 so that this particular term also comes in kilojoules only. And when you solve this equation, as far as I remember, the value comes out to be almost 37.5 kilojoules. This is the internal energy change during the vaporization of 1 mole of liquid water, which I was supposed to calculate. Am I clear with this? Am I clear with this, people? Am I clear with this quickly? Yeah? This sort of a question I have already showed you in the marathon also. I hope you guys remember it. Look at one more question, guys. Read the question carefully and try to solve this question. It's a simpler one. Predict in which of the following entropy increases or decreases. Entropy increases or decreases. The first process is saying a liquid crystallizes into solid. The first process is saying that your liquid is getting converted into solid. And you students, it's evident. When liquid gets converted into solid, when liquid is converted into solid, what happens to the disorderness? Disorderness decreases, right? Because in solid, you have got a proper arrangement, right? In solid, you have got a proper arrangement of constituent particles. Perfect. So when liquid gets converted into solid, I would say disorderness decreases. And if disorderness decreases, what does that mean? That means entropy decreases. So in the first process, the value of capital S, that's entropy, that will be decreasing throughout the process. Okay. Look at the second point. Temperature of the crystalline solid is raised from 0 Kelvin to 115. So you are raising the temperature of solid. And you know, when you raise the temperature of the solid, what will happen to its entropy? What will happen to disorderness? Disorderness will increase. And if the disorderness increases, that means entropy is going to increase. Simple as that. Look at the third one. Look at the third one. We are given with a reaction. My dear students, on the reactant side, you are going to the solid, right? Reactant side solid. Product side solid, gas, gas, right? So on reactant side, you have got only solid. On product side, you have got gases as well. So what would be happening to the disorderness throughout the process? During the process, disorderness would be increasing because your solids are getting converted partially into gases as well. Perfect. So disorderness will be increasing. If disorderness is increasing, that means entropy would be increasing, right? So entropy is increasing in this process. As simple as that. Look at the next one. H2 gas gives 2 times H gas. How do you check this? Over here, the stoichiometric coefficient is 1. Here, the stoichiometric coefficient is 2. So when this process is happening, number of moles are increasing. 1, 2. Number of moles are increasing during the process. And if moles are increasing, particles are increasing. As the particles increase, disorderness increases. As the disorderness increases, I would say entropy would automatically increase. So this is how you are going to solve these sort of questions when asked. Okay? I believe I'm clear with this. I'm moving on to one more question. I am moving on to one more question. Look at this question, guys. Calculate delta G naught for the conversion of oxygen to ozone. Reaction is given, temperature is given, Kp value is equilibrium constant is also given to us. Okay. Now see people, if you look carefully, the reaction is given to us as 3/2 O2 gas. 3/2 O2 gas. It gives us what? It gives us O3 gas. Perfect. Reaction is carried out at temperature 298 Kelvin. What am I supposed to calculate? I am supposed to calculate delta G naught for the reaction. I'm supposed to calculate delta G naught for the reaction. I believe you all will be remembering one formula which I've already given you. Delta G naught is equal to 2.303 RT log of equilibrium constant. Do you remember this expression? This expression I have given you in the chapter electrochemistry as well. I hope you remember that. Now you just need to put the values and get the question done. So it's going to be 2.303, R value taken joules, 8.314 joules per Kelvin per mole. Temperature is given to me as 298 Kelvin, and it's going to be log of equilibrium constant. Equilibrium constant is given to me as 2.47 into 10 raised power minus 29. Now it is just the matter of calculation, and after solving, you are going to get the answer in joules over here, right? So final answer in joules is going to be 163,000 joules per mole. If you want to convert it in kilojoules, so divide with 1000. So it's going to be 163 kilojoules per mole. I believe you can solve this sort of a question easily, right? If you do not know how to get the value of log of 2.47, use the approximation. Use the approximation. Log 2 is how much? 0.3. Log 3 is how much? 0.47. So log of 2.47 would be in between these two values. So you can use the approximation here. That's all. Or maybe in the question, they would be giving you exact value of log 2.47. Perfect. Don't worry about this particular thing. I hope I'm clear with this. Let's move on to one more question. Let's move on to one more question. At least this sort of a question, everybody should be able to solve. Then I would think that you have studied thermodynamics. Because it's a very simple question, which in the when we start teaching thermodynamics, this is the first thing which we teach basically in the basic terminologies. Choose the correct answer. A thermodynamic state function is a quantity. State function. State function. State functions depend on initial and final state, and at the same time, they are path independent. I hope you remember. State functions are path independent. Perfect. State functions are path independent. You should know it. Path functions, they also depend on initial final state, but at the same time, they are path dependent. They are path dependent. A very simple and basic question this was. All right, next one. For the process to occur under adiabatic conditions, the correct condition is, see what kind of question this is. I mean, you should be able to kill this question in less than 5 seconds, not more than that. For the process to occur under adiabatic conditions, the correct condition is adiabatic. Adiabatic means no heat exchange between system and surroundings. Adiabatic means no heat exchange between system and surroundings. Therefore, Q value has to be 0. Therefore, Q value has to be 0, right? Therefore, Q value has to be 0. Okay, one more simple and basic question which you should remember by now. The enthalpies of all the elements in their standard state. It's basically, he's talking about the enthalpy of formation. Enthalpy of formation of an element in their standard state is taken as enthalpy of formation of an element in its standard state is taken as 0. I hope you remember. This is one of the basic statements which I believe everybody would be knowing. Standard enthalpy of formation of an element when present in its standard state. When present in its standard state is taken as 0. Correct? Done and dusted. Look at this particular question. In the process, 701 joules of heat is absorbed by the system. Heat is being absorbed by the system. And whenever heat is absorbed by the system, Q value is taken to be positive. So Q is plus 701 joules, number 1, right? And 394 joules of work is done by the system. Work is done by the system. And whenever work is done by the system, the value of W in chemistry is taken to be negative. So it's going to be minus 394 joules. This is the value of W. Well, if you have Q, if you have W, you can easily calculate internal energy change, delta U. So delta U is nothing but Q plus W. Q value you know, W value you know. Put the values, get the value of delta U here, right? Again a simple one. Again a simple one. Again a simple one, yeah? This sort of a question is easy and you call them as the easy kill questions. You call them as the easy kill questions. Look at this one. Calculate the number of kilojoules of heat. Calculate the number of kilojoules of heat. So we are supposed to calculate heat, Q. Calculate the number of kilojoules of heat necessary to raise the temperature of 60 grams of aluminium. 60 grams of aluminium means how many moles of aluminium? Mass of aluminium in grams divided by molar mass of aluminium, right? Calculate the amount of heat required to raise the temperature of 60 grams of aluminium from 35 degree to 55 degree. So change in temperature. Delta T, 35 degree to 55 degree is 20. Molar heat capacity of aluminium is given to me as 24 joules mole inverse Kelvin inverse. Right? All this stuff is given. Perfect. What am I supposed to calculate? I'm supposed to calculate Q. My dear students, one result is there, which I believe all of you will be remembering. Do you remember this particular result? Q is equal to N Cm delta T. Q is equal to N Cm delta T. If you look at this particular equation, N value is given to us, Cm value is given to us, delta T change in temperature is given to us. By putting all these values here in this expression, can't we get the value of Q here, which will come out to be in joules? Again, a simple and basic question. Again, a simple and basic question. Right? Again, a simple and basic question. Perfect. Similarly, let me move on to one more. Let me move on to one more. Look at this one. It's again the NCERT exercise question, which is mentioned here. Enthalpy of combustion of carbon to carbon dioxide. Enthalpy of combustion. So we are doing the combustion of carbon. Combustion of carbon means carbon plus O2 O2 gas, it gives carbon dioxide gas, right? It gives carbon dioxide gas. So 1 mole of carbon is undergoing combustion. When 1 mole of carbon undergoes combustion, enthalpy change of the reaction at that point of time is something which I call as enthalpy of combustion. This is the enthalpy of combustion of carbon that's given to me, and as per the question, it's minus 393.5 kilojoules per mole, right? Calculate the heat released upon the formation of 35.2 grams of carbon dioxide. Calculate the heat released upon the formation of 35.2 grams of carbon dioxide. So as per the question, we are supposed to form 35.2 grams of carbon dioxide. So how many moles of carbon dioxide are we supposed to form? Check it out. Mass of carbon dioxide in grams divided by molar mass of carbon dioxide. So these many moles of carbon dioxide we are supposed to form. Now, my dear students, one thing. If you look at this particular reaction, in this particular reaction, 1 mole of carbon is undergoing combustion, right? Perfect. At the same time, if you see, 1 mole of carbon dioxide is formed. At the same time, if you see, 1 mole of carbon dioxide is formed, right? And in this particular reaction, how much heat is released? 393.5 kilojoules of heat is released. Can I say from this particular equation, I can say just one thing. When 1 mole carbon dioxide is formed from the above reaction, how much heat is released? 393.5 kilojoules of heat is released when 1 mole of carbon dioxide is formed. Am I supposed to form 1 mole of carbon dioxide? I'm supposed to form these many moles of carbon dioxide. So I would say when 35.2 divided by 44 moles of carbon dioxide are formed, how much heat would be released? Matter of calculation. 35.2 divided by 44 multiplied by 393.5 kilojoules. So this much amount of heat would be released during the process, right? This much amount of heat would be released during the process. I believe you can easily solve this sort of a question as well. Am I clear with this? Am I clear with this, people? State in the chats once. Did you understand how did I tackle this? How did I solve this? It's a simple question. Simple one. Perfect. All right. Let's move on to one more question. Look at this question, guys. For the reaction which is given to me, delta H is given and delta S is given. At what temperature will the reaction become spontaneous? Considering delta H and delta S to be constant over the temperature range. Well, I believe you remember one thing. For any process to be spontaneous, delta G for the system at constant pressure and temperature, it has to be negative. This is the criteria for spontaneity, by the way. This is the criteria for spontaneity. So, for any process to be spontaneous, delta G for the system at constant pressure temperature, it has to be negative. Okay. Now, what is delta G? Basically, delta G is nothing but delta H minus T delta S. So, this particular term has to be negative. Perfect. What is delta H? 400 kilojoules. So, these many joules minus. What is T? Okay, we can do one thing. Since this is kilojoules, so we can take in kilojoules also, or if you want to take in joules, you can do that too. Temperature, I need to calculate. Delta S is given to me as 0.2 kilojoules. 0.2 kilojoules means 200 joules, right? It means 200 joules. This particular term has to be negative. I'm just putting the values. This particular term has to be negative. So I would say 400,000 has to be less than 200 times capital T. Or I would say 200 times capital T has to be greater than 400,000, right? Or temperature has to be greater than 400,000. Temperature has to be greater than 400,000 divided by 200. So 0000 cancels out. So it comes out to be what? We are left with 4,000 here. 4,000 divided by 2 is basically 2,000 Kelvin. Perfect. You can check the calculation afterwards as well. Was there anywhere sign negative? No, sign was not negative anywhere. So I would say temperature has to be greater than 200 Kelvin, then only the reaction would be spontaneous, right? Perfect, guys. Did you understand how to deal with this particular question? Perfect. Temperature should be greater than 2000 Kelvin, then only the reaction would be spontaneous. Okay. Look at this one. This is something which you should be able to solve on your own. The question is, for the reaction 2 times Cl gas gives Cl2. 2 times Cl gas, it gives what? It gives Cl2 gas. This is the process. What are the signs of delta H and delta S? Tell me. What are the signs of delta H and delta S? First of all, let's talk about delta S. See guys, on the reactant side, you're starting with 2 moles. On the product side, you've got only 1 mole. So when this process is happening, I would say moles are decreasing. If moles are decreasing, that means particles are decreasing. Particles decreasing means disorder decreasing. Decrease in the disorder means entropy decreasing. So entropy is decreasing, so delta S has to be negative in this case. Delta S has to be negative. Now, if you look at this particular process, you have got 2 chlorine atoms and they are forming Cl2 molecule. So bond formation is taking place. Bond formation taking place. Bond formation is exothermic, right? And for exothermic processes, delta H is negative. So delta H has to be negative as well. Perfect. Am I clear with this? Right, people? So this was again a simple question, which I believe you can easily solve. You can easily solve. Look at this one. A similar type of question which we already solved in the beginning itself. A similar type of question. You should be able to solve this one too. The question is, equilibrium constant for the reaction is 10. What would be the value of delta G naught? This is something which you should be solving in less than 10 seconds, guys, right? You know, delta G naught is nothing but 2.303 RT and the log of equilibrium constant. Perfect. So it is 2.303. R value is 8.314. Temperature must be given to me as 300 Kelvin, right? And it's a log of equilibrium constant. And equilibrium constant is how much? Equilibrium constant is 10. Log 10 is 1. Just solve this particular term and get the answer. The answer is going to come in joules over here. And if you want to convert this in kilojoules, then you will have to divide this particular term with 1000 as well. Then you will be getting the answer in kilojoules. I hope I am clear with this as well. Okay. All right. This is one basic question. And these sort of questions also come in your examination at times, right? Simple, easy-kill questions. Out of internal energy, boiling point, pH and EMF, intensive properties are. See, first of all, when you talk about internal energy, enthalpy, entropy, Gibbs free energy, those are all your extensive properties. So this is extensive in nature. When you talk about your boiling point, if you talk about your boiling point is an intensive property. You should be knowing it, right? Boiling point is an intensive, size independent. pH of the solution, it's also size independent. It's intensive. EMF of the cell is also intensive. It is also intensive, right? So what is going to be the answer of this question? Now we can select your options. Simple, right? Perfect. Let's move on to one more question. Look at this one. Molar entropy and temperature are. It is molar entropy. See, first of all, entropy is an extensive property. Entropy is an extensive property. But you should be knowing, whenever an extensive property is expressed per unit mole, per unit mass, or per unit volume, the new property, which I'm here calling as molar entropy, it becomes intensive, right? Whenever an extensive property is expressed per unit mass, per unit mole, or per unit volume, the new property always becomes intensive. So molar entropy is intensive. Entropy is extensive, but molar entropy is intensive. And temperature already you know that is intensive. Temperature already you know that is intensive. Right? Perfect. All right. Which of the following are not the state functions? Dear students, if you remember the thermodynamics marathon, I would have taught in detail. In your path functions, you have got heat and work. Heat and work are your path functions. Perfect. Q plus W is internal energy. Q plus W is basically your internal energy. That's a state function. Right? H minus Ts is basically your Gibbs free energy. That's also a state function. So this is the path function. This is the path function. The question was, which of the following are not state functions? So 2 and 3, they are not state functions. 2 and 3 are not state functions, they are path functions. Correct? I believe this is also clear to everyone. Okay, I am moving on, guys. Talk about this particular question. Look at the question carefully and tell me its answer. When freezing of liquid takes place, when liquid freezes, what happens? What happens? When liquid freezes, when liquid gets converted into solid, is heat absorbed by the system or heat released? Heat is released by the system. When liquid freezes, heat is released by the system. And whenever heat is released by the system, Q value, as per sign convention, is taken to be negative, right? Q value is taken to be negative. So it has to be option C. That is going to be the correct answer of this particular question. Yeah? Perfect. Let's move on to one more. This sort of a question, again, it should not take more than 5 seconds to solve. This question, again, should not take more than 5 seconds to solve. The question is 3 moles of an ideal gas expanded spontaneously in vacuum. Work done is. Expansion in vacuum is what you call as free expansion. And in case of free expansion, the value of W is? In case of free expansion in vacuum, the value of W is 0. Right? I believe you all are clear with this. Okay. A given mass of the gas expands reversibly from state A to state B by 3 paths. Path 1, path 2, path 3. W1, W2, W3 represents the work respectively, right? We have to give the order of the work. My dear students, you should be remembering one thing. I hope you remember it. Area under PV curve. Area under PV curve gives us what? It gives us the magnitude of work. Area under PV curve, it's a PV curve given. And area under PV curve, it always gives us magnitude of work. So, if you look carefully, look at the path 1. I would say this is area. This is area under path 1, right? What is area under path 2? What is area under path 2? Look at it carefully. This is area under path 2, right? What is area under path 3? I would say this is area under path 3. So where is the area under the curve more? Area under the curve is more in 3, followed by 2, followed by 1. Area under the curve gives us the magnitude of work. So W3 has to be, magnitude of W3 has to be greater than that of magnitude of W2, which has to be greater than that of magnitude of W1. Perfect? Right, people? So when will be the expected date for NEET 2025? It will be 4th, 5th May, something like that. Like the first Sunday in the first week of May. That's going to be your exam. All right. Guys, even this particular question, it should not take more than 5 seconds to solve. It should not take more than 5 seconds to solve. 1 mole of an ideal gas at 25 degrees centigrade expands in vacuum from 1 liter to 4 liters at constant temperature. What work is done if the gas expands against vacuum? This is again the same question, guys. Expansion in vacuum is something which you call as free expansion. Expansion in vacuum is something which you call as free expansion. And in case of free expansion, W value is taken to be 0. Right? So, correct answer is simply option 4. No need to solve this. One simple and basic question. Look at this. Even this particular question, it should not take more than 20 seconds to solve. An ideal gas is allowed to expand from 1 liter to 10 liters against a constant external pressure. They have mentioned a term against a constant external pressure. And you know, when external pressure is constant, the process is considered to be what? Irreversible. The process is irreversible. And in case of irreversible processes, how do we calculate work? Work is calculated by the formula minus P external delta V, right? So what is P external? What is external pressure? External pressure is 1 bar, delta V, change in volume, final minus initial, that's 9 liters. So the unit of this particular term, pressure, the unit of this particular term is pressure, is bar, volume, I'm taking liters, so it's minus 9 bar liter, minus 9 bar liter. I need to calculate work in kilojoules. This is the value of work in bar liter, right? You must be knowing 1 bar liter is equal to 100 joules. So it is going to be minus 900 joules. If you want to convert this in kilojoules, so divide this particular term with 1000, you'll be getting the answer as minus 0.9 kilojoules. This is the value of W which I was supposed to calculate. I believe I'm clear with this. Right? Right, people? Perfect. It's a simple basic question. You just have to take care of the units. That's it. You have to calculate the answer in kilojoules. Right? I hope I'm clear with this. Let's move on to one more question then. The question says the molar heat capacity of water at constant pressure. Molar heat capacity of water at constant pressure, Cp value, is given to me as 75 joules Kelvin inverse mole inverse. Cp value is given. As per the question, when 1 kilojoule of heat is supplied to 100 grams of water, when 1 kilojoule of heat, 1 kilojoule means 1000 joules, right? So, when 1000 joules of heat is supplied to 100 grams of water, 100 grams of water means how many moles of water? It is 100 divided by 18. So, this much heat is supplied to these many moles of water. Perfect. When this much of heat is supplied to these many moles of water, which is free to expand, the increase in the temperature of water will be. So, delta T I'm supposed to calculate. Delta T I'm supposed to calculate. Now, how will you be solving this? It's again a simple question, guys. You know, your QP, heat absorbed or heat released by the system at constant pressure, it is equal to NCP delta T. This is one of the expressions which I would have given you in the marathon itself, right? QP is equal to NCP delta T. What am I supposed to calculate? Delta T. So how do you get delta T over here? It's just going to be QP divided by NCP. What is QP? QP is given to me as 75. Sorry. QP is given to me as 1000. QP is given to me as 1000 joules. Divided by N value is 100 divided by 18. And CP value is how much? CP value is 75. This is the matter of calculation. Solve it. You'll be getting the answer in Kelvin here. That's it. Done. Now people are saying the answer is 2.4. All right. If the answer is coming out to be 2.4, then it has to be 2.4 only. Right? So basically, when you are supplying 1000 joules of heat to 100 grams of water, the temperature of water will be raising by 2.4 Kelvin. Okay? Perfect. One easy question, not less than 3 seconds to solve. For 2 moles of ideal gas, Cp minus Cv is. For 1 mole of ideal gas, Cp minus Cv is R. For 2 moles of ideal gas, Cp minus Cv is 2R. For n moles of ideal gas, Cp minus Cv is nR. So the answer of this particular question is going to be 2R. Nothing to think here. Nothing to think. Which of the following expressions is true for the ideal gas? Which of the following expressions is true for the ideal gas? Look at the expressions. My dear students, as I see the options, see, first of all, internal energy of the ideal gas depends only on temperature. Right? For a fixed amount of ideal gas, its internal energy only depends on what? Its internal energy only depends on temperature. If internal energy depends only on temperature, tell me, which of the following statement is true then? What do you think? Tell me which of the following statements is true then. Quick. You should be able to solve this, guys. See, this particular term is mentioning here that temperature is keeping constant. We are keeping the temperature constant. If we are keeping the temperature of the ideal gas constant, since internal energy of the ideal gas depends only on temperature for a fixed moles of gas. For fixed moles of ideal gas, its internal energy only depends on temperature. If you are keeping the temperature constant, if you are not letting the temperature of the gas to change, its internal energy won't change, right? So, change in internal energy due to change in volume, keeping temperature constant, it will be 0. Option C is the one which is correct. Yeah? Perfect, guys? Alright, look at this particular question. Even this sort of a question you should be able to solve quickly. You should not take a lot of time to solve this question. Check it out. In a closed insulated container, insulated means Q is 0, no heat exchange between system and surroundings. A liquid is stirred with a paddle. So we have got a container in which liquid is kept. Now liquid is being stirred. Liquid is my system. So work is done on the system. Work is done on the system. Work is done on the system. Work is done on the system, right? So would the value of W be 0? No, it would be non-zero. Work is done on the system. Some amount of work is done on the system. Which of the following is true? Now it's done. If Q is 0, but W is non-zero, use the first law. Delta U is equal to Q plus W. Q value is already 0. So delta U has to be equal to W. And W is already non-zero. So I would say Q has to be 0. Delta U has to be equal to W. But both would be non-zero here. Now select the options. I believe it's option 1. That is going to be the correct answer of the question. Right? I hope this is clear to everyone. Now, moving on to one more question. Let me see if you can solve this or not. It's a simple basic question, guys. You should be in a position to solve this question in not more than 20-30 seconds. What do you think? Give it a try. Quick. A system undergoes a process in which delta U, as per the question, delta U is given to us as 300 joules. Number 1. While absorbing 400 joules of heat, system absorbs heat. When system absorbs heat, Q value is taken to be positive. So it's plus 400 joules. Undergoing an expansion against 0.5 bar. So P external is given to me as 0.5 bar. What am I supposed to calculate? I'm supposed to calculate change in volume delta V in liters. I'm supposed to calculate delta V in liters. Just use the first law of thermodynamics and you are done. First law says that your delta U has to be equal to Q plus W, right? And since expansion of the gas is happening against constant external pressure, so the process has to be irreversible. When process is irreversible, I'll say delta U is equal to Q. Instead of W, I'll write minus P external delta V. Minus P external delta V. Now, delta U is given to me as 300 joules. Q value is given to me as 400 joules. P external is given to me as 0.5 bar. Delta V I have to calculate in liters, right? If this is in joules, then this particular term should be in joules too. But this particular term right now is in bar liter. So convert it in joules. You know, 1 bar liter is equal to how much? 100 joules. So multiply it with 100. Now this particular term, now this entire term is going to be in joules as well, right? And when you solve this equation, you'll be getting the value of delta V from here, which is change in volume. It will come out to be 2 liters. So the answer of this particular question is going to be option C, right? I believe I'm clear with this particular question as well. All right. Okay, look at this one, guys. Even this is a very simple basic question. You should be in a position to solve this. During compression of a spring, so we are given the spring, that's our system, and we are compressing the spring. If we are compressing the spring, what does that mean? That means work is done on the spring. We are compressing the spring. That means work is done on the spring. And whenever work is done on the system, W value is taken to be positive in chemistry. So W has to be equal to plus 10 kilojoule. Number 1. Number 2. 2 kilojoules of heat escape to surroundings. 2 kilojoules of heat escape to surroundings. So heat is going from system to surroundings. If heat is going from system to surroundings, that means system is releasing heat. And when system releases heat, Q value is taken to be negative. So it's minus 2 kilojoules. You know the value of W, you know the value of Q. Get the value of delta U. So delta U has to be equal to Q plus W. Q value is equal to minus 2 kilojoules. W is equal to 10. The value comes out to be 8 kilojoules. Right? This is the value of delta U, which I was supposed to calculate. Done and dusted. Right? Perfect. Perfect, guys. What do you think is the answer of this particular question? Delta U is equal to which work? Is delta U equal to isochoric work? Is delta U equal to isobaric work? Is delta U equal to adiabatic work or isothermal work? Even this is the asked question. Even this is the asked question. You know, delta U is equal to Q plus W. First of all, tell me one thing. When can delta U be equal to W? Delta U can only be equal to W if Q is 0. Right? Delta U can only be equal to W if Q is 0. Q is 0 means adiabatic process. Q is 0 means adiabatic process. Perfect. So delta U, I would say, has to be equal to which work? It is adiabatic work. So delta U is equal to W adiabatic. So it's option C. That has to be the correct answer of this particular question. I believe I'm clear with this particular question. If I'm clear, let me know once in the chats quickly. If I'm clear with this particular question, let me know in the chats quickly. Amazing, guys. Let's move on to one more simple question which you should be able to solve. This sort of a question again should not take more than 20 seconds to solve. It should not take more than 20 seconds to solve. See, just use your common sense a bit. When 1 mole of the gas is heated at constant volume means W value 0. First thing, constant value means W value 0. If W is 0, first law, delta U is equal to Q plus W. So delta U has to be equal to Q. This is something which I got till now. W 0 and delta U has to be Q. From just one line I got this statement. The temperature is raised from this to this. If heat supplied to the gas is 500, how much heat is supplied to the gas? 500 joules. When heat is supplied to the gas, that means heat is absorbed by the gas. When heat is absorbed by the gas, Q value is taken to be positive. So Q has to be plus 500 joules. If Q is plus 500, that means delta U also is plus 500. Done? So delta U has to be equal to Q, has to be equal to 500, and W value has to be 0. Which option is satisfying that? Delta U is equal to Q is equal to 500 and W value is equal to 0. So it's option 2, which is the correct answer of this particular question. You're not supposed to solve the question. You're not supposed to get the values, etc., etc. Just read the question, use the logic, and kill the question. That's all. And these are your NEET standard questions, guys. Proper NEET. Even these sort of questions are asked in your JEE Mains examination too. Okay? All right. Moving on. Moving on to one more question. Look at this one. Look at this one. A system expands from, system means ideal gas. A system expands from 5 liters to 10 liters against a constant external pressure. Against constant external pressure of 2 atm. If external pressure is constant, the process is irreversible. If it absorbs 800 joules of heat, system is absorbing heat, so Q value is plus 800. Q value is plus 800. Calculate the value of delta U. We have to calculate the value of delta U in joules. We have to get the value of delta U in joules. It's a simple basic question, guys. First of all, in order to calculate delta U, you know delta U is nothing but it's equal to Q plus W. So in order to get delta U, we should have the value of Q, and Q value we already have. Process is irreversible. So let's get to know W irreversible first of all. How do you calculate work done in irreversible processes? It is nothing but minus P external delta V. Minus P external is how much? 2 atm. Delta V, change in volume, is 5 liters. The answer over here is going to be in atm liter. But I do not need this particular term in atm liter. I want this in joules. So it's going to be minus 10. Instead of 1 atm liter, I'm writing 101.3 joules. So the value is minus 1013 joules here. So this is the value of W. If you got the value of W, if you got the value of Q, you can easily get the value of delta U. So delta U has to be equal to, what is Q? Q is 800 joules. W is minus 1013 joules. The value comes out to be minus 213 joules. This is the value of delta U, which I was supposed to calculate. People are saying option 3. Yes, you all are right. It's option 3. All right. This is one more question, guys. Look at the question carefully. For 1 mole of ideal gas, enthalpy versus temperature curve is given. Identify at which point the value of Cp is higher. Identify at which point the value of Cp is higher. You know, in case of the ideal gas, you should know it. In case of the ideal gas, dH is equal to NCp dt. This is the equation which I believe everybody would have studied, right? And this is the equation valid for which gas particularly, ideal gas. dH is equal to NCp dt. If I'll be having 1 mole of ideal gas, that means N is 1. If N is 1, I would say Cp is nothing but dH upon dt. Cp would be dH upon dt for 1 mole of ideal gas. Now, my dear students, what is dH upon dt? dH upon dt means slope of the tangent. Slope of the tangent at a point. Slope of the tangent at a point on enthalpy versus temperature curve. dH upon dt means slope of the tangent at a point. Where? On enthalpy versus temperature curve. Can I say wherever the slope of tangent is more, Cp value has to be more? Absolutely. Wherever slope of tangent is more, the value of Cp has to be more. So, if I draw a tangent here also, if I draw a tangent here also, where do you see the tangent has got more slope? The tangent has got more slope at A. More the slope of the tangent, more is going to be the value of Cp. So I would say Cp at A would be greater than that of Cp at B. This is something which I was supposed to calculate here. Yeah? Perfect, guys. Look at this particular question. Assume each reaction is carried out in an open vessel. Which reaction will have delta H equal to delta U? Delta U or delta E, you can say. See, first of all, my dear students, you know, your delta H is nothing but it is delta U plus delta NGRT. Delta H is nothing but delta U plus delta NGRT. When can delta H and delta U be equal? I would say delta H and delta U can only be equal if delta Ng for the reaction here would be 0, right? If delta Ng is 0, then only I can say delta H and delta U are equal, right? Now, in which of the following reactions delta Ng is 0? If you look at the last reaction, in the last reaction, delta Ng is 0. Number of moles of gaseous products are 2. Number of moles of gaseous reactants are also 1 plus 1, 2. So 2 minus 2 comes out to be 0. So delta Ng for this particular reaction is 0. And if delta Ng is 0, that means your delta H and delta U are supposed to be equal. Yeah? Perfect. I believe this particular question is clear to everybody. Right? Okay, a similar sort of question. Tell me the answer of this. It is the JEE Mains PYQ. See what kind of question was asked. A reaction is given in this format. C3H8 gas plus 5 times O2 gas. It gives 3 times carbon dioxide gas plus 4 times H2O liquid. This is the reaction which we have. We are supposed to calculate the value of delta H minus delta U. Delta H minus delta U value we are supposed to calculate. Whether you want to say delta H minus delta E or delta H minus delta U. Because internal energy is either represented by U or E. Right? Now, first of all, if I want to calculate delta Ng for this reaction, delta Ng for the reaction is equal to number of moles of gaseous products, which is 3, minus number of moles of gaseous reactants, which is 1 plus 5, that is 6. The value comes out to be minus 3. So delta Ng for this reaction is minus 3. If delta Ng for the reaction is minus 3, you know, delta H is equal to delta U plus delta NGRT, right? So I can say delta H minus delta U has to be equal to delta NGRT. What is delta Ng here? Delta Ng here is minus 3, so it is minus 3 RT, right? I was supposed to get this value only, delta H minus delta U. It is coming out to be minus 3 RT. So this is going to be the answer of this particular question. I believe it's clear. I believe it's clear. Right? I believe it's clear. Okay. Look at this one. Look at this one, guys. Calculate the work done in joules when 4.5 grams of H2O2. 4.5 grams H2O2 means how many moles of H2O2? Mass of H2O2 in grams divided by molar mass of H2O2. What is the molar mass of H2O2? It is 34 grams. So these many moles of H2O2 we have. Perfect. Reacts against a constant pressure of 1 atm. So basically we are supposed to calculate the work done. We are supposed to calculate the work done. Okay. We are supposed to calculate the work done. How do we calculate the work done? This particular result, I believe you would have studied somewhere. W is equal to minus delta NGRT for the reactions particularly. What is the delta Ng for the reaction? The value of delta Ng for this particular reaction is 1. It's 1. R value I'll be taking as 8.314 joules per Kelvin per mole. And temperature is given to me as how much? 25 degrees centigrade. That means 298 Kelvin. This is the value of W which I got in joules. But if you look carefully, this is the value of W when 2 moles of H2O2 are participating in the reaction. This is the value of W for the 2 moles of H2O2. When 2 moles of H2O2 are getting converted into O2 and water, this is the value of W. Perfect. So I would say when 2 moles H2O2 or 2 moles of H2O2, what is the value of W? Value of W is minus 8 multiplied by 298 joules. This is the value of the W. Therefore, if I use the unitary method, for 1 mole of H2O2, what is the value of W? For 1 mole, it's going to be divided by 2. So it's going to be minus 4 into 298 joules. Perfect. But do we have only 1 mole of H2O2 or these many moles? We have got these many moles of H2O2. So I would say 4.5 divided by 34 moles of H2O2, right? Will have the value of W as minus 4 into 298 multiplied by 4.5 divided by 34, and the answer is going to be in joules. Did you understand? Did you understand, people? Did you understand? This was the value of W for 1 mole of H2O2. We are not having 1 mole of H2O2. We are having these many moles of H2O2. Correct? So you need to be careful with this particular stuff as well, right? This particular stuff is asked in the exam. All right. Look at this one. Look at this one. A gas expands against a variable pressure. Variable pressure means process which one? Reversible or irreversible? It's a reversible process. A gas expands against a variable pressure. So if it is mentioned as variable pressure, so it's a reversible process. Pressure is given to me as 20 divided by V. Pressure is in atm, volume is in liters. During the expansion from the volume of 1 liter to 10 liters. From the volume of 1 liter to 10 liters, the gas undergoes a change in internal energy. The gas undergoes a change in internal energy of 400 joules. Calculate how much heat is absorbed by the gas. Calculate Q. Q we are supposed to calculate. We are supposed to calculate the Q. Now, my dear students, if you look at the question carefully, right? First thing, how do I calculate W in this particular process? W reversible. How do we calculate work done in reversible processes? Minus integral V1 to V2. It is going to be P gas multiplied by dV. Now, my dear students, V1 is nothing but 1 liter. V2 is 10 liters. P gas is given to me as 20 divided by V multiplied by dV. So if I take minus 20 out, integral of 1 by V dV is ln of V. It's ln of V, 1 to 10. Now, minus 20 as such, it's going to be ln of 10 minus ln of 1, right? Your ln of 1 is 0. Ln 10 is 2.303. So, minus 20 multiplied by 2.303. Minus 20 multiplied by 2.303, which comes out to be how much? 2 3s are 6, 0, 6, 4. So, it's going to be 46.06. But the units here, since I have taken pressure in atm, volume in liters, the units are going to be in atm liter right now. If the units are going to be in atm liter, you can convert them into joules as well, right? This is the value of W. And the sign here is minus. Perfect. So it is minus 46 multiplied by 101.3. Then the answer is going to be in joules. This is the value of W. My dear students, you got the value of W. What am I supposed to calculate? Q. You know, delta U is equal to Q plus W. Perfect. So Q has to be equal to delta U minus W, right? So Q is equal to, what is the value of delta U? That's 400 joules minus, what is the value of W? W value is this much, 46 into 101.3. Check, do the calculation and get the value of Q. That's all. Done? Done with this, people? Done with this? Yeah? I hope I'm clear with this. And after solving, answer of this particular question will come out to be this. This is the final answer of the question. You're not supposed to calculate work in this question. You are supposed to calculate Q. So do not confuse yourself. You got the W as 46. And over here, they would have given one option as 46. But you're not supposed to get W. W is 46, no doubt. But you're supposed to calculate Q, not W. So be careful. Answer of this question is this. Okay, moving on. Look at this question, guys. Look at this particular question. Why I multiplied with 2.303? Because ln of 10 value, that is 2.303. For the real gas, a reaction is given, delta H is given. In a 10-liter rigid vessel, a reaction is taking place in a 10-liter rigid vessel. Rigid vessel means volume constant. Initial pressure is given to me as 70 bar. Okay. After the reaction, final pressure is given to me as 40 bar. What am I supposed to calculate? I'm supposed to calculate delta U, internal energy change. How do I get this? Again, a simple question. You know, volume is constant. When volume is constant, you know delta H is equal to delta U plus V delta P. I hope you remember this equation. This is the equation which we use when volume of the system is constant, right? So, delta H. What do I need to calculate? I need to calculate delta U. So, delta U has to be equal to delta H minus V delta P. What is delta H? Delta H is minus 560 kilojoules, right? Minus, what is the value of V? Volume. Volume of the vessel is 10 liters. Change in pressure. Final minus initial. Final minus initial is minus 30 minus plus multiplied by 30, right? Bar. So this is bar, this is liter. So this particular term is in bar liter. This particular term is in bar liter. This particular term is in kilojoules. Now, I cannot directly add or subtract them because this is in bar liter, this is in kilojoules. I have to make units same. You know, 1 bar liter is equal to how much? 100 joules. So I'm multiplying this with 100. So now I'm getting this particular term in joules. I'm getting this particular term in joules, but I need it in kilojoules. So I'm dividing with 1002. Then only I'll be getting this particular term also in kilojoules. Now just the matter of calculation. Get the delta U for the process. Right? Perfect. This sort of a question, I believe you can easily solve. Look at this question, guys. Look at this particular question. 1 mole of a non-ideal gas undergoes a change in state. 1 mole of a non-ideal gas undergoes a change in state. 2 atm, 3 liters, 95 Kelvin. To what? To 4 atm, 5 liters, to 45 Kelvin. These are the initial state parameters of the gas. These are the final state parameters of the gas. I would say the state of the system is changing because since the value of state parameters is changing, pressure of the gas initially was 2 atm, finally it's 4 atm. So pressure of the gas is changing, volume is also changing, temperature is also changing. So I would say if the value of state parameters here is changing, and if the value of state parameters change, the state of the system automatically changes, right? And if the state of the system changes, there'll be change in the value of every state function. There is a change in the value of every state function. Well, as per the question, internal energy change due to the change in the state is given to me as 30 atm liter. 30 atm liter. What do I need to calculate? I need to calculate delta H. First of all, if you see, pressure is also changing, volume is also changing, temperature is also changing. Which equation do we use in this particular scenario? I hope you remember I have given you this equation. Delta H is equal to delta U plus it's going to be P2 V2 minus P1 V1. Now, delta H is equal to, what is the value of delta U? Delta U is given to me as how much? 30 atm liter. Okay, plus 30 atm liter plus P2 V2. P2 multiplied by V2. 5 4s are 20. So this is 20 minus P1 into V1. P1 into V1. 3 2s are 6. 20 minus 6 is 14. So there's an atm liter too. So 30 plus 14 comes out to be 44 atm liters. Delta H will be equal to 44 atm liters, which I was supposed to calculate. I believe this is clear. Yeah? Is that clear, guys? I hope you would be able to solve this survey question on your own from now on. Okay. Look at this one. Look at this one. 5 moles of N2H4 undergoes complete decomposition. Calculate the work done in calories. A reaction is given. Calculate the work done. W is equal to what? Minus delta Ng RT. You know it already. Now, what is the delta Ng for the reaction first of all? Delta Ng is equal to number of moles of gaseous products, which is 4 plus 1, 5. Minus number of moles of gaseous reactant, which is nothing. So delta Ng is equal to 5. Delta Ng is equal to 5. Right? Yeah? Now, my dear students, understand properly. If you want to calculate W, W is equal to minus delta Ng. What is the value of delta Ng? 5. What is the value of R? Since I need to get the work in calories, so I would be needing R value in calories. That's 2. Temperature is 27 degrees centigrade, which is 300 Kelvin. So 5 2s are 10. It is minus 3000 calories. If you think this is the answer of the question, no, it's not. This is not going to be the answer of the question. This is the value of W when 3 moles of N2H4 are undergoing decomposition. I would say when 3 moles of N2H4 undergo decomposition, what is the value of W? The value of W is minus 3000 calories. If I use the unitary method, I can say when 1 mole N2H4 undergoes decomposition, what has to be the value of W? It is going to be minus 3000 divided by 3. The value comes out to be minus 1000 calories. This is the value of W for the decomposition of 1 mole N2H4. Now, as per the question, do we have 1 mole of N2H4 or 5 moles? We have got 5 moles of N2H4. So when 1 mole N2H4 undergoes decomposition, this is the value of W. And hence, when 5 moles of N2H4 undergoes decomposition, what has to be the value of W? Minus 1000 multiplied by 5, which comes out to be minus 5000 calories. So this is the value of W which I was supposed to calculate. I believe I'm clear with this. Yeah? I believe I'm clear with this particular question too. Okay. All right. Look at this question. Calculate Q, W, delta U, and delta H in calories when 2 moles of ideal gas. When 2 moles of an ideal gas. 2 moles of an ideal gas are expanded reversibly and isothermally. When 2 moles of ideal gas are expanded reversibly and isothermally. Isothermally from the pressure of 10 atm to the pressure of 5 atm. Right? At 27 degrees centigrade. So first of all, the process is isothermal. And you know, when ideal gas undergoes isothermal process, delta U has to be 0. If delta U is equal to 0, that means your Q plus W has to be 0. If Q plus W has to be 0, then Q has to be equal to minus W. Q has to be equal to minus W. Right? So I just need the value of one of them. Other one, I can easily calculate. Since the process is reversible, how do we calculate work done in reversible isothermal processes? It is nothing but minus nRT ln of P1 divided by P2. Now, what is N value? N value is 2. R value, taken calories, that's 2. Ln of P1 by P2. P1 is how much? 10 by 5 is 2. And as per the equation, ln 2 value is given to me as 0.7. So 2 into 2, and temperature I missed here. What is the temperature? Temperature is 27 degrees centigrade. That means 300 Kelvin. Perfect. So it's going to be 2 2s are 4. 4 3 12. So 1200 multiplied by 0.7 is going to be 1200 multiplied by 0.7 is going to be 840. So the value of W is equal to minus 840 calorie. If the value of W is minus 840, so Q value will come out to be plus 840 calories. Q value is equal to plus 840 calories. So what was I supposed to calculate? I was supposed to get the value of Q. Q value I got to know as plus 840. W value I got to know as minus 840. Now, since the process is isothermal, and you know when the ideal gas undergoes isothermal process, delta U as well as delta H for the gas would be 0. So option 1 is the one which is correct. Right? One is saying show the solution, sir, after solving the question. This is the solution only which I am showing. What am I showing? What else do you see here? What else do you see here? Check this one. During isothermal expansion of an ideal gas, what happens? Isothermal process. When the ideal gas undergoes isothermal process, delta U has to be 0 as well as delta H has to be 0. For the ideal gas undergoing which process? Undergoing isothermal process. For the ideal gas undergoing which process? Isothermal process, right? If delta U is 0, what does that mean? That means internal energy remains unaffected. It remains same, constant. Enthalpy also remains constant. Enthalpy also remains same, it remains constant. It does not change. That's why their change in their values is coming out to be 0. So you can easily solve the question now. During isothermal expansion of an ideal gas, nothing happens to enthalpy. And nothing happens to enthalpy, nothing happens to internal energy, right? Perfect. All right. Look at this one. Look at this one, guys. Adiabatic expansion of an ideal gas. Adiabatic means Q is 0. All right, Q is 0. Delta U has to be equal to Q plus W. Since Q is 0, delta U has to be equal to W. Right? This is something which I got till now. Now, during adiabatic expansion of an ideal gas, expansion means W value negative. Expansion means W value negative. If W is negative, what does that mean? That means delta U is negative. If delta U is negative, that means NCV minus T1 is negative. If NCV minus T1 is negative, that means T2 has to be less than T1. So, during adiabatic expansion of an ideal gas, temperature of the system decreases, right? Temperature of the system decreases. Perfect. Temperature of the system decreases. Or you can say internal energy of the system decreases. That's why delta U is coming out when I get to here. So what is the option? What is the option, people? What is the option? What is the answer of this particular question? It has to be option. It has to be option. Option 1. When the ideal gas undergoes adiabatic expansion, internal energy of the ideal gas decreases. Therefore, temperature of the ideal gas decreases. Or I can say ideal gas undergoes cooling. And opposite of it, when the ideal gas undergoes adiabatic compression, internal energy of the gas increases, temperature of the gas increases, or I would say ideal gas undergoes heating. Right? Perfect, guys. Do you remember this expression? Work done in case of reversible adiabatic. Work done in case of reversible adiabatic. You should know it. It is P2 V2 minus P1 V1 divided by gamma minus 1. I hope you remember this particular stuff. Right? Basically, in case of reversible adiabatics, adiabatic Q is 0. Therefore, W has to be equal to delta U. And delta U for the ideal gas is nothing but N CV T2 minus T1. Right? So it's N. CV is nothing but R divided by gamma minus 1. T2 minus T1. This can be one of the expression, one of the formula. NR T2 minus T1 divided by gamma minus 1. Or instead of NR T2, I can write P2 V2. Minus. Instead of NR T1, I can write P1 V1. Divided by what? Divided by gamma minus 1. This can be one more formula. Either you can say NR delta T divided by gamma minus 1, or you can say P2 V2 minus P1 V1 divided by gamma minus 1. Okay. And my dear students, I'm stopping here. Or let me solve one more question and then we'll stop. But the PDF which I'll be sharing of this particular chapter, right? This particular PDF which I'll be sharing, in that PDF you'll find 20 more questions that you guys are going to solve on your own. Okay? The PDF which I'll be sharing on my Telegram, Wassim Bhat Chemistry Official, right? Right after the session, I'll be sharing that PDF. That will contain some 20 more questions which you guys are going to solve on your own. Perfect? Look at this one. The correct option for free expansion means W0, all right, of an ideal gas undergoing adiabatic process. Adiabatic means Q is equal to 0. If W0, Q0, as per first law, delta U has to be 0. If delta U has to be 0, that means NCV delta T0, which means delta T also has to be 0. Now find the options. Q0, W0, delta U0, delta T0, everything 0. So which one? It's going to be option 4. Perfect? And your homework question, whose answer you are going to let me know in the comment section of this video, that is going to be this question. Simple basic question I'm giving you. This is a homework question whose answer you will tell me in the comment section of this video right after the session ends. Not in the chats. Not in the chats. In the comment section. In the comment section right after the video ends. And the PDF which I'll be sharing of this particular chapter, it contains almost like 20 questions which you guys are going to solve on your own. Those are your, again, homework questions only. Answer of this question I would want in the comment section. But answer of those questions, you can keep it to yourself. Right? And I believe you can solve them. Okay? And my dear students, the next top 100 questions is going to be for General Organic Chemistry GOC, which I'm going to which I'll be taking on day after tomorrow. Day after tomorrow, there is one more session scheduled for me, top 100 questions of the chapter GOC. Do not miss that session at all. Do not miss that session at all. Okay? Chalo, with this I'm taking a leave. I'll see you guys day after tomorrow. Till then, you guys take care. God bless you. Love you all. And do let me know in the comment section of this particular video if you are liking this particular question practice series a lot. Do let me know about that. Perfect. Do let me know honestly. I would need some honest replies, honest feedbacks from you about this particular series. Okay. So take care. God bless you all and love you all, guys. Bye-bye.